All right, let's work on basic right triangle trig. Our first review problem, simplest polynomial with roots of 3, 5, and -2 would look like x minus 3, x minus 5, and x plus 2. We multiply some of these together, these first two. If we multiply together, we're going to get x squared minus 8x plus 15. We then multiply that by x plus 2. We'll use the area model for that so we don't lose track of anything. And we get an x cubed minus 8x squared plus 15x plus 2x squared minus 16x plus 30. And so in this form it looks like x cubed minus 6x squared minus x plus 30. All right, what is the inverse of this thing? Well, we write inverses by first of all making the arrow diagram. So let's multiply by 2 and then add 1. Then that is a cube root. We will do a log base 6 of, and then multiply by 3. The cube root is one that we may not have done a lot with just yet, but now to find the inverse, we move the x from the beginning to the end and work our arrows back. So we've got a divide by 3. The opposite of log base 6 is 6 to the power. The opposite of a cube root is cubed. The opposite or inverse of adding 1 is subtracting 1. The inverse of multiplying by 2 is dividing by 2. So we're going to take an x divided by 3, put that in the power of 6, take that whole thing and cube it, then subtract 1 and divide everything by 2. That would be f inverse of x. Now, is there simplifying we can do? Certainly this power to a power rule, we could combine those. That looks like it will just be a 6 to the x minus 1 all over 2. All right, on to the new stuff. Find the exact values of sine, cosine, and tangent in this. So what we know right now for this angle is the adjacent side and the hypotenuse. We don't know yet what the opposite side is, but adjacent and hypotenuse, we can write cosine for that. So the cosine is the adjacent divided by the hypotenuse. 2 divided by 2, we can make 1 over root 10. And some people would say you can't leave a square root in the denominator, so we're going to multiply by root 10 over root 10 and get square root 10 over 10. I am fine with this answer right there. Okay. If we're going to find the other ones that require the opposite side, then we're going to have to find the opposite side, and we'll do that with the Pythagorean theorem. We know 2 squared plus the thing that we don't know squared has to equal 2 times the square root of 10 squared. So that's 2 squared plus x squared equals 4 times 10, which is 40. That's going to give us an x squared equals 36, so the x must be 6 on this side. So our sine theta is the opposite over the hypotenuse. That's 6 over 2 root 10, which reduces to 3 over root 10, or 3 times the square root of 10 over 10. And the tangent of theta is opposite over adjacent. That's 6 over 2, which is 3. Okay. All right, so we've got that answer. Again, I'm fine with those answers right there. We've at least reduced the fractions. Use special right triangles to give exact values of cosine of 60 degrees and tangent of 60 degrees. Well, if we make a 30, 60, 90 triangle, short side is 1, the hypotenuse is twice as big, this is the square root of 3, so the cosine of 60 is the adjacent side, over the hypotenuse, that is exactly 1/2. And the tangent of 60 degrees is the opposite side over the adjacent. That's going to be exactly square root of 3. Moving company is using ramps on its trucks that are 6 feet long if the floor of the truck is 30 inches above the ground. So we've got the back of the truck here, and this distance is 30 inches. Got some wheels back here somewhere. And they're using a ramp that is 6 feet long. We probably better get all the units talking to each other. 6 times 12 is 72, so that's 72 inches, and this is 30 inches. And they want to know what the angle of the incline is, so that would be that angle. For looking, we have opposite and hypotenuse. That must be sine. So our sine theta is equal to the opposite divided by the hypotenuse. And so the angle will be the inverse sine of 30 over 72. Probably want this in, I'm going to make sure my calculator is in degree mode. And I will type in the second sine of 30 over 72. It gives me about 24.6 degrees. Okay, an observer on a sea cliff with a height of 12 meters. So, sea, cliff, this is 12 meters. Spots an otter through a pair of binoculars at an angle of depression of 5.7 degrees. So here is my otter out here. I know it doesn't look a lot like an otter. Maybe it does. Here's the line of sight. Angle of depression always measured from a horizontal. So this is the 5.7 degree angle. This is 12 meters. How far from the otter, from the base of the cliff is the otter? So we're trying to find this. If that's 5.7, then the otter's angle of elevation, and looking back at the observer on the cliff, is also 5.7 degrees. And this is the opposite, is the 12 meters. We want to know the adjacent, so we must be using tangent. So the tangent of 5.7 is 12 over x, or x then is equal to 12 divided by the tangent of 5.7. We're expecting a number much bigger than 12 on this. So 12 divided by the tangent of 5.7 is about 120 meters. Okay. All right, 5 minutes later, the observer in problem number 6 sees the same otter at an angle of depression of 7.6 degrees. Is the otter closer or farther away? Well, that means that the observer would have had to look down at a more steep angle, so the otter must be closer. If we want to know how much closer, we need to know what this distance is in our picture, and we can find this distance that I have labeled x here now, because we know this is 7.6 degrees. So we know that the tangent of the 7.6 degrees is 12 over x. So x must be 12 divided by the tangent of 7.6 degrees. See, the otter is now about 90 meters away. So how many meters has the otter moved? Well, it was 120 meters away. Now it's 90 meters away. So it is about 30 meters is how far it has moved. All right.